Hello and welcome to the next lecture in our 19th chapter of our comprehensive course on AI, machine learning and data science. Now in this lecture, we want to do how the concept of permutations and combinations, which was introduced in the previous chapter, is used in the data science. We as such took many practical examples where both concepts are used, but now from data science point of view. So one is in the feature selection and subset generation. For example, in machine learning, we often select a subset of features to find the best model. Now at that time, you have to decide which subsets are to be kept and how many such different combinations would be possible. So what I am saying is, suppose you have total 10 features. What are features? Then this is one example which I have taken. Say some heart failure clinical records, actual data set is there, and from which I imported it, and these are called my features. That age, whether the person has anemia or not, his creatinine, phosphokinase, diabetes, ejection fraction of his heart, high blood pressure, platelets, serum creatinine, serum sodium, sex or gender, smoking, whether the person is a smoker or not, time, that is the follow-up, how many times he has come, fourth time or sixth time, how much, that is his which visit it is, okay, and depending upon, and the death event. Death event is whether during this whole follow-up process, okay, the death occurred or did not occur. So 1 means death occurred during the process, and 0 means death did not occur during the whole follow-up process of 8 visits. And these are normally, say, aged people. Suppose you can see their age 75, 55. So in the top 5 rows head, there are lot many dead people. Okay, let us see the tail perhaps, just to get a slightly rosier picture, because this is, yeah, in the tail I can see that slightly younger population is there, last 5 records, and there the death event is 0 for all the records. But that is okay. Suppose I am making a I want to make a model which will predict, these are 298 records, okay. Now I want to make a mathematical model which can predict that given these same features, these features which are shaded by blue color at present, if 100 new patients come and I measure these features for those 100 new patients, then what is the probability of any one patient whose features I supplied and the model should give me his probability, and I can decide some threshold that if probability is greater than 50%, then I will say that it is death event is 1, and if the probability is less than 50%, then I will say that that person is less not likely to die. Now instead of 50%, you can select any other thing, maybe 30% or 80%, depending upon how much risk you want to take with your patients. But suppose I take the usual 50% cutoff. So if I put some this kind of values for some new patient, that is 299th patient comes, and for him I put these values, and I get that the probability is 65%. So that is above that 50% threshold. So I would have to say that death is likely to occur during my follow-ups, and I can even decide also that how many follow-ups would be required and so on. In short, I am building a predictive model. And these are my features, and this is my response variable, whether death will occur or not occur based on probability. Now the question is, should I take all these features, or should I take some limited number of features? Because earlier we have done some little bit of discussion that as such, if you take all the features, then your model will be such that on the given data set, it will give very, very accurate results. But that is because it has been trained on the 80% fraction of this data set itself. But the question is, when new 100 patients come, then on that, the performance of that model will not be so accurate. That phenomena we call overfitting. And to reduce overfitting, there are multiple methods, but one of the methods is to make your model simpler or to reduce model complexity. So as a result of that, what do is, you select that these are so many features are there, but I can maybe remove one feature. For example, suppose I decide that this gender has not much effect, so remove it. Then maybe it is just I'm randomly saying anemia has not much effect, so I remove that. Similarly, suppose this smoking has not much effect, so I remove that. So 3 features I have removed, and only the remaining features I am keeping. This process is called feature selection, in which I am generating a subset of features from given features. These are my given features, but I am not using all of them to make my model, because as I said, that model will be overfitting. So what I do is I take a subset, but then I should be, before choosing which features are to be selected, I should be able to decide how many such subsets would be possible. Okay, so suppose we take an example like this, that you have 10 features in the data set. So here actually I think there are 12 or 13 maybe, but these are suppose 10, and this is your response variable, death event. And out of 10 features, you want only 3 features to be kept. So that means you want to remove 7 features. You want to build a very simple model, and the most important 3 features you want to keep. Okay, so for that, what you can do is, you can find how many such combination of 3 features are possible, because 3 I want to take only 3, that is fine, but which 3? One person says I want to take these 3, another person says no, I want to take anemia, these and these, another person will say no, I want to take this. Then these are just in the same line, but some person may say no, I want to take, say, smoking, I want to say take that CM creatinine, and I want to take maybe ejection fraction, and then I will decide. So there are how many such 3 combinations are there by selecting by which I can select 3 features out of 10 features, suppose. So then that can be found by C 10, 3, and we have done the formula, so we know that that is n factorial upon n minus r factorial into r factorial. Okay, so n factorial upon n minus r factorial into, in the denominator only, r factorial. So here 10 factorial upon 10 minus 3 factorial, that is 7 factorial, divided by 3 factorial. Now in the numerator I can write 10 multiplied by 9 multiplied by 8 multiplied by 7 factorial. Okay, and then 7 factorial and this 10 minus 3, 7 factorial, that will be cancelled. So what remains in the numerator? 10 multiplied by 9 multiplied by 8. Okay, and what remains in the denominator? 3 multiplied by 2. So that 3 multiplied by 2, that 3 also, and in the 10 multiplied, okay, let me write this. So then in the numerator what has remained is 10 multiplied by 9 multiplied by 8. Okay, and in the denominator what has multiplied by 7 factorial was there, but that 7 factorial would be cancelled with this 7 factorial in the denominator, right? And divided by 3 factorial, so that is 3 multiplied by 2 multiplied by 1. Okay, so there is 6, so maybe this is 2 4s are, so here this 4 will remain, and in the denominator 2 will be now cancelled, and 3 3s are, so in the numerator 3 will remain, and this in the denominator 3 will also be cancelled. So it is actually now 10 3s are 30, 4s are 120. So there are how many possible simple models? If I select only 3 features from 10 features, then there are 120 different simple models which I will have to build, and then I have to test the accuracy of each model on the test training data and testing data. So that means total 240 times I will have to measure the accuracy or precision or recall or various quality metrics which decide the goodness of it. And then I will find that the best model is suppose obtained by taking high blood pressure, ejection fraction, and creatinine phosphokinase. Then I will say that I will forget about the remaining, because this model out of 120 models which was obtained by taking these 3 features, that gave the best result. But again the problem is, will you do it by manually? Then no, there are ready-made ready-made methods by which we will do. Then the Python is so powerful. As we grow further and further in our course, and as our requirements will become more and more sophisticated, then you will see that Python becomes more and more capable, and it always handles our requirement. So Python will do something so that all these 120 models will be tried, and among them we can find the best model automatically. Okay, so here these are the features, and this is the description of that feature. That is just I have put for the information that what is the meaning of these features. But this is one example where combinations are useful. So you should understand, when we use automated tools, there are automated tools in Python which do this feature selection for you, and they will give you the best possible 3 features, or they will just ask you how many features you want to select. So if I select 3 features, then you should realize that how much time that algorithm is saving for you. That means it is internally testing 120 different models on train set and 120 different model on test set, and then finds a model which is having the best possible, say, accuracy or F1 score or precision or recall on both train and test set, and that model is presented to us that use these 3 features. Now, can you understand how much time is saved if all these things are done automatically, and we don't have to try one by one, try these 3, then try these 3, try these 3, like that? Okay. Similarly, there is one another thing that is called hyperparameter tuning. Now, the model selection algorithm, model training algorithm, the data scientist decides by seeing the data distribution, and he decides that here linear model will fit or here non-linear model will fit. So suppose you have decided some algorithm, maybe random forest, or maybe, now what is random forest, don't worry, but maybe you have decided that if the algorithm which I want to try is random forest, and the hyperparameters which I want to try are these. Okay, now what are these hyperparameters? So suppose there are 3 hyperparameters, and one hyperparameter is learning rate. Don't bother, I'm just coming to what is that. And there are 5 possible values of learning rate. Another hyperparameter is depth, in which there are 4 possible values of depth. So one has to select 1 out of 5 values for the learning rate, 1 out of 4 values for the depth, and 1 out of 3 values for the regularization strength. Okay, and once you select them, you say that you have selected your 3 hyperparameters. So hyperparameter selection does not only mean selecting that I want to use learning rate, depth, and regularization strength. Okay, in addition to selecting the hyperparameter, you have to select which value you want to use. For learning rate, there are 5 values: 0.01, 0.02, 0.03, 0.04, and 0.05. For depth, there are values, say 5, 10, 20, and 25. And for regularization strength, suppose there are values like maybe 2, 4, and 6, 3 values. So you can make how many possible combinations of the hyperparameters for the same algorithm in random forest. Okay, I'm not talking about other algorithm, but in random forest, there are so many possible ways in which random forest can be applied. So how many possible ways are there? Then it is found by permutations, because here this position will matter. So then P 5 1 multiplied by P 4 1 multiplied by P 3 1. Now permutations was defined in this manner, that n factorial upon n minus r factorial. So 5 1 means that will be 5 factorial upon 5 minus 1 factorial, that is 4 factorial. Okay, so any number multiplied by 1, that is permuted 5 factorial, say 5p1, that is what I am using. Okay, so that is in the numerator 5 factorial, okay, and in the denominator 5 minus 1 factorial, because that is the definition, n factorial divided by n minus r factorial. Okay, so 5 minus 1 whole outside factorial, but 5 minus 1 is 4 factorial. So actually that means what, that it is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, but that whole thing 4 multiplied by 3 multiplied by 2 multiplied by 1 can be written as 4 factorial, and then divided by in the denominator 5 minus 1 whole factorial, so that is also 4 factorial. So 4 factorial will be cancelled. So in that case what you will get is just 5. So any number combination permutations with 1 is always that number itself. So 5p1 that is equal to 5, 10p1 that will be 10, 4p1 that will be 4, and 2p1 that will be 2, yeah, like that. So then it is very easy to find that 5p1. So that means that would be equal to 5. Here p41, so that is 4, and this p31 that is 3, and therefore how many possible ways in which hyperparameters can be tried? So then 5 multiplied by 4 multiplied by 3, or 60 possible ways in which I can apply random forest. Now think about the complexity of the business for a data scientist. First he has to choose several one model out of several models. So maybe linear regression, logistic regression, maybe, okay, or say suppose classification is decided, so logistic regression, then SVM, then maybe KNN, then random forest, XGBoost, neural network. So that is already a choice of one among many algorithms. So suppose you are trying one among 10 algorithms. So here it will be one more term will be added, P10-1, because you are choosing one algorithm out of 10 different algorithms. So then how many possible choices will be there? 600 choices, because I am multiplying by P10-1, but P10-1 would be 10. So multiplying by 10 means 600. So I have to try 10 algorithms. Then I have decided, I have to try different 600 values. Or suppose I have already decided my algorithm, that my algorithm will be random forest. Still, for random forest only, I have to try 60 different values with just 3 hyperparameters. Okay, so you can understand that how complex this will be if one manually tries to make first random forest model, then second random forest model, third random forest model, fourth, by choosing different values of this hyperparameter, learning rate and all that. Then in that case, he will have to make 60 models, and then he will have to find the best model which gives the highest accuracy, F1 score, etc. That would become the best possible model, and he has to use that model for his further processing. Okay. Now, if one has to do again this whole thing manually, then there is going to be a big trouble. So fortunately, we have again one automated method. That method is called grid search CV, cross validation. So grid search CV automatically tries all possible combinations, all 60 combinations, and tells you that take learning rate is equal to 0.02, take depth is equal to 5, and take regularization strength is equal to 8. That will give you the best random forest model. Now and it in a fraction of a second it gives the answer. So when it gives the answer, we hardly realize how much work that grid search CV has done. It has tried 60 different random forest model and then gave you the best possible values of 3 hyperparameters. So this hyperparameter tuning is one more example of use of permutations. Okay. Now here we want to take one actual data set, and don't worry about many of the things which you don't understand. Here we are just importing libraries. Here we are loading iris data set, and we are dividing it into 2 parts, x and y. X is my feature variable and y is my target variable. Just like here, this is my features, all features, and if I include only this much part of my data set, then that is called feature matrix. And if I include only this much part, death event and one column of death event, that is called response matrix, or it is also called response vector, because it is always a single column, so it can be called vector or matrix, whatever you want to like. So x is that feature matrix and y is my response matrix. Since it is small, it is shown by small letter, because response matrix is only one column, while feature matrix is very large. You can see that this many columns and all these rows that together makes x. So then I am dividing my data into this part, and then these x and y I further divide into train set and test set. So these are the 2 divisions of x. 80% of the data is in train, and 20% of the data, that is 0.2. Here I have written test size is 0.2, that is 20%, is in test. Okay. Then similarly, y is also divided into test set and train set. So y is 80% of the data is in train, and 20% of the data is in y test. Now, when we train the algorithm, at that time we don't expose this X test and Y test to the algorithm. Okay, so that means entire training process will be done by 80% of the data. So only algorithm is only exposed to this X train and Y train, 80% of the data points. Okay, let us select some model, that random forest classifier. This is just a seed, so that every time we execute this code, we will get the same result. Otherwise, it starts randomly, then it will give different answers. Now this is that grid set, hyperparameter grid. Now here how many hyperparameters are there? Here three were there: learning rate, depth, and regularization strength for some other algorithm. Now here how many hyperparameters are there? N estimator, max depth, minimum sample shift, split, and minimum sample leaf. Okay. So now I am not explaining what are these, but this has three possible values here. This has four possible values. This has three possible values, and these also has three possible values. Okay. So let us select the grid search CV. So that grid search CV will be estimator is equal to model, means estimator is equal to random forest. I have already chosen my algorithm, and parameter grid is equal to parameter grid. So it will try, this grid search will try all these combinations one by one. How many such combinations can be? So that I will show you the calculation. It will be even more than that 60 case, because here there are four parameters, right? So then I use grid search CV, and it automatically tries all these values one by one, all these combinations one by one, and gives you the best possible hyperparameters and best possible accuracy. Okay, so then you have to choose the value of those best possible hyperparameters, and that will give you best model, and then you can use prediction, use it to make the prediction. And don't worry at all if you don't follow this code. Okay, because this is the business which we are going to do for rest of the so many of the chapters, that this will become like second nature for you. So even in your sleep, you will be able to do this. So currently my purpose is not that to how to make the model and how to fit the model and all that. My purpose is simple. I just want to show that if grid search CV, that automated method would not be there, then how difficult it would be to adjust so many hyperparameters. So my purpose is just to show the applications of grid search CV. Okay, and if I execute this code, then you will see that it will take some time, because grid search CV tries so many different numbers of these parameters. So it takes some time, but still you can see quickly how quickly it has given answer. Now fitting 5 folds for each 108 candidates, totaling 540 fits. So that means here it was 60 possible random forest or whatever model was there. Here it has tried how many different models? 540 different models. Okay, and then he found that take max depth equals none, minimum sample lift is 2, minimum sample split is 2, and number of estimators is equal to 150. What are they? Don't worry about them at present at all. But this number of estimator should be 150. This max depth should be none. Minimum sample split should be 2, and minimum sample leaf, this parameter should be 2, and these also should be 2. That gives the highest accuracy, and the highest accuracy is nearly 0.95.833%. Okay, or here we are getting even 100%, but that is because this is synthetic data set. In practical data set, 100% would not be obtained. But nowadays the algorithms have become so powerful that getting 95% accuracy is very well possible. Okay, now trying 540 different combinations from these hyperparameters and giving you the best hyperparameter combination, that it does only in 5 to 6 seconds. Or suppose your PC would be slightly lesser configuration, then it might take say 30 seconds. But if you try to do this manually, it will take days or maybe months, and there is every chance that we will make some mistake in the calculation. So this is one application where hyperparameter tuning is one application where these permutations and combinations are used. And one more application, last application, is probability in sampling and resampling. Now there is not much code and nothing, so I am taking this in this lecture itself. There are many probability based tasks such as bootstrapping. Now again, don't worry about what is this bootstrapping. We have to do a little detailed discussion of this, otherwise the course would be completely lacking in the quality. So we will do when it is required. Monte Carlo simulations, again this Monte Carlo is usually used for time series data and many other things. But in that, you have to take sampling without replacement. Permutations and combinations are very useful for sampling. Sampling means what? That you have possibly, suppose 10,000 observations, but you want to apply certain statistical tests on only that many observations, which are enough to give sufficiently accurate conclusion. Then, as I earlier also said, that there is a central limit theorem which says that when certain conditions are satisfied, what are that certain conditions, that we will see when we will see that central limit theorem. But when certain conditions are satisfied, then around 40 or greater than 30, any number of observations, they are enough. So in that case, suppose I am doing some task, some test, say recommendation system is being made, and I am asked the probability of selecting a subset of user for testing. So I have my data for 100 users which are purchasing on my online shopping platform. Okay, then I want to select 10 users at a time. As I said, 10 would be a very small sample. Around minimum 30 is the recommended size of sample. But just as an understanding, suppose I want to select any 10 users from 100 users, and here order is not important. Where you put them, any 10 out of 100. Okay. So then in that case, how many possible ways I can make such a sample? So then the number of ways to select the group. Order is not important, so I will use combination n comma r, where n is what the total pool of observation, so that is 100, and r is what? R is the number of subset or sample which I want to choose from the entire pool of observation. So that is here 10. So that is n combination n comma r. The formula was here, that was this formula, this, okay, that is here n factorial upon n minus r factorial into, in the denominator only, into r factorial. Okay, so that same formula I am applying here. So here I will add one line at the bottom, and okay, so then what will be C 100 comma 10? That means how many possible ways are there to select 10 customers out of a pool of 100 customers? So that would be 100 factorial. Now can you imagine, that would be 100 multiplied by 99 multiplied by 98 multiplied by 97 multiplied by 96 multiplied by so on and on and on and on and on, multiplied by suppose 11, then multiplied by 10, and then multiplied by 1, 9, 8, and so on up to 1, but that is itself 10 factorial, right? Okay, divided by 10 factorial. Okay, so 10 factorial and multiplied by 100 minus 10, so that is 90 factorial. Okay, so then I should have thought about it, that there was no need of all this. I could have taken only here 95 multiplied by 94 multiplied by 93 multiplied by 92, and this is 93. Okay, multiplied by 92 multiplied by 91 multiplied by 90, and then multiplied by 89, and so on up to 1. Okay, so that whole thing is called 90 factorial, right? So 90 factorial, and then 90 factorial will be cancelled. So what will remain is, that means these numbers in the numerator, these numbers, this, and divided by, in the denominator it would be 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, now if try to find this, I am using my calculator just as a maybe trial. Okay, or you can make this as numpy array and you can use it that way also, or maybe just I am using my browser, maybe Google, I think, will be able to calculate that. Okay, yes, it is 2.279, or that is 2.28 roughly, into 10 raised to 24, or that is 228 into 10 raised to 22, or 228 and 22 zeros. Okay, 228 and then 1, 2, 3, 4, 5, 6, 7, 8. This many possible combinations are there in which I can select 10 persons from a pool of 100 persons when order is not important. Now, how difficult the sampling task is. Okay, again, fortunately, we have automated methods which do the random sampling on our behalf using just code. There are libraries which you have to import, and you just have to use sample or resample like that, and it will do all that combinations. Okay, so that is about permutations and combination. 2 lectures, this and the previous one, that were required so that some idea is needed, some idea is inserted in the mind of learner about the how many possible events are there, and among them, if you want to do certain limited number of events, then what are your chances? For example, as I said, if you want to get selected in India's cricket playing 11, then what are your odds? Then all those things become clear when you learn about permutations and combinations. Now in next lecture, and that will also take 2 lectures, I think, we will into 2 or maybe 3 also. Simple probability, we want to discuss about probability. Okay, so we'll stop here. Thank you, and see you in next lecture.